Hello and welcome to section 3.5. Today we're going to be graphing equations in radian mode. Trigonometric functions like sine of theta means theta is measured in degrees. But now we have circular functions which have sine of x. So notice the distinction between an x and a theta. Now x is going to be an indicator that is measured in radians. So whenever you see the word circular function or an x after the sine or cosine or tangent, then you'll know that we want our answer in radians. If it's using theta, it's a trigonometric function, and it will be in degrees. So if I say draw 2 cycles of sine of theta, I'll want you to draw 2 cycles like this. This would be sine of theta, so that would be 360 degrees. This would be 180 degrees. It would be 90 and 270. We could continue every 90, filling in the rest of the graph. If I wanted to graph sine of x, now we're doing the same thing, but it's going to be in radians. So it's going to do a full cycle in 2 pi and half a cycle by the time it gets to pi. Over a quarter of the way would be pi over 2, and 3/4 would be 3 pi over 2. Now we can continue labeling the rest if we wish. Now the period of sine of x is 2 pi. Just like because the sine of theta is 360 and 2 pi is equal to 360 degrees. The amplitude of sine is the same with the phase displacement. So the only thing that changes is the x-axis in what we label. All right, let's take a look at this graph. There is an x in the graph, so we automatically know that it's in radians. The amplitude of the function is going to be this 3 right there. Phase displacement, we're moving it to the right 3. Vertical displacement, we're going up 5. The horizontal dilation factor would be 1 over this. So we're going to multiply the function by 4 over pi. So the period is usually 2 pi, which we'd take 2 pi divided by this number, which is pi over 4, which is 2 pi times 4 over pi. Now, if when I multiply, I go straight across, so that's 8 pi over pi, which is just 8. Now notice horizontal dilation factor, that's what we multiply by our function. So 2 pi times 4 over pi, that's what gives us this. So our period is going to be 8. All right, so now let's graph this function. So we have to scale this out, so I'm going to go up 5. And I'm going to draw my sinusoidal axis. 1, 2, 3, 4, 5. There's my sinusoidal axis. I'll go up 3, and then I'll go down 3. I move to the right 3 to start my graph, and cosine starts on the top. Now, the one thing we have to think of that is, or we found out it was the period was 8. So I need to go 8 to the right of this. 1, 2, 3, 4, 5, 6, 7, 8. And that's where it's going to start the function again. Right in the middle. It's going to be in the middle, or be at the bottom, and then between that it's going to hit the middle. So our function is going to come around, hit the bottom. Oop, that was a little wide. And then it's going to continue to the left, and it's going to continue to the right, but that's one cycle of this graph. All right, so now if this says plot for cosine of 5x. Now we can do this on our calculator, but what this does is it takes the period, so the period is normally 2 pi, and we're shrinking it by a factor of 5. So the period is just 2 pi divided by 5, even because the horizontal dilation factor is 1/5. All right, now tangent. Oh, so what I should do is, if I want to graph this real quick, what we'll do is we'll go 4 above, and 4 below. And it's cosine, so it starts on the top. We'll do a full cosine. And it does a full cosine in 2 pi over 5. It can do another full loop by the time it gets to 4 pi over 5. So we can continue this 6 pi over 5 and so on and so on. All right, if we take a look at this, the horizontal dilation factor is 1 over this, so that would be, we're going to multiply by 6 over pi. Now finding the period, we have to think that tangent is usually has a period of pi. So we take pi divided by what is shrinking by, so pi over 6, which is going to be pi times 6 over pi. Those pi's will cancel out, so our period will just be 6. Our phase displacement is 0. We don't move it to the right or left, and we don't move it up or down. So when I sketch the graph of this, all I have to keep in mind is its tangent, but it repeats 6 to the right. I know tangent goes through 0, 0. If I go 6 to the right, it's going to also pass through that point. In between the zeros are my asymptotes. So it's going to hit here at 3. It's going to go here at 9. And then at 12. So even at, we can have another asymptote at -3. So what we do is we start at the bottom, come up. Ooh, I missed it. Pretend I didn't miss it. And then we come through, pass through the 6, and go up. And it'll keep going with this pattern. So notice the only thing that I've changed here is the scaling on the x-axis. All right. Now if you can, pause this video and try to find the equation of this function using sine. That's 7. This is 1, 2, 3, 4. All right. So the first thing we do, we know it goes from -1 to 7. So the sinusoidal axis will be at 3. And if you draw this through, it looks like 3 is a good sinusoidal axis. So we can say this is y equals 3 plus, goes up 4 and down 4, sine of, looks like it passes right through the middle, so it doesn't move to the right or to the left, and it does 1 rotation until it's a little after 3. I would guess that that point right there is probably pi. So it shrinks by a factor of 2, because usually sine has a period of 2 pi, and since this function is only pi, I shrunk that by a factor of 2. All right, try this one. This is 1, this is 5, 10, -1. First thing I'll do, hopefully you've paused it and gone through this. We're going from 1 to -5, so it looks like -2 would be in the middle. So I'll start my equation, y equals -2. I'm going up 3 and down 3. I move to the left 1. Now, it looks like this distance here goes from -1 to 11. So that's 12 units. So to find this number here, what I do is I take 2 pi, what it normally takes cosine to do a rotation, and I divide it by 12. Now, the only thing I can reduce here is the 2 and the 12, so that would be pi over 6. So y equals -2 plus 3 cosine pi over 6, x plus 1. All right, now try to do this one using cosecant. All right, first thing we do is we draw a center of our function. We can draw this as if it's the sine. So it looks like y equals 4 plus 2 cosecant. Looks like it passes through 4, so that it doesn't move to the right or to the left. It does an entire rotation by the time it gets to 4. So we're gonna do 2 pi over 4, which is just pi over 2. So 4 plus 2 cosecant of pi over 2, x. All right, hopefully that was good for enough for you guys to understand and do the homework. Good luck.